Episode of the Future of Farming today, where we show you where agriculture is going, where it is now, and how we're going to get there. Okay. Now, today's episode is very exciting because we're going to show you how you can reduce your water and input costs by 25 to 50%. Now, I know that sounds like a big claim, and I know that a lot of you are probably thinking, okay, here's another slick salesman trying to sell you something. But I really just wanted to take this episode and this time to really just educate you some of the things that we've been talking to farmers about because we've been talking to so many farmers over the last several months, and we've really gotten a feel for how farming is done around the world. And it's done obviously very differently depending on the crop and the climate and a lot of different factors. But what we've started to see in again when you have conversations with so many farmers, you get a broad view of how things are being done and you start to see similarities. Okay. Now, one thing that we see, one trend that we see quite often when we're talking to farmers is a certain irrigation schedule, right? And a lot of times it will be depending upon whatever has worked, like whatever they've noticed seems to be the best. But the funny thing is that with farming, a lot of times you'll just have kind of a knack, right? No, your dad did it this way, or an agronomist told you to do this and it seemed to work, so you just stay with it. And if something kind of works, if it ain't broke, don't fix it type of thing. But a lot of times there's not a lot of analysis that goes into that. It's just sort of let's try this and see if it works. Well, interestingly enough, a lot of things that we've seen is some of our farmers have been trying different things as they use our crop booster. They've been experimenting with different irrigation schedules and different input schedules and different things. And that's allowed them to be a lot more precise in how they apply water and nutrients, which is a big part of your cost, right? Now, just to give you an idea, if you're, I don't know, a corn farmer, let's say you're spending $400 or $500 an acre on your input costs. And let's say you're putting 2 or 3 acre inches on your, per acre inches on your land as you irrigate, right? You think, okay, well, that's how much the crops need. Well, what we've seen with a lot of our growers is by reducing the amount of hours per schedule, and sometimes that's not possible. For example, if you're a corn farmer and you're running that pivot 24/7, that pivot can only go around so fast, and so you have a certain limitation there. But if you're a drip irrigation farmer or you're using flood irrigation, then there's a lot of room for improvement. And what we are recommending, especially when people are using our crop booster, because our crop booster technology makes plants a lot more efficient so that they don't need as much water and nutrients. So, in many cases, with our farmers, we're telling them don't irrigate for as long, right? So, if you're irrigating on a 2 hour cycle, 2 hours once or twice a week, maybe irrigate 15, 20 minutes, but do it every day. Or instead of irrigating once a week for, let's say, 12 hours, just run a whole flood type of a situation, see if you can irrigate twice a week and maybe only do it 4 hours, not six, but four. Why do I say that? Because when you irrigate more often, then you don't have to flood and saturate the ground as much because the water, it takes a few days to dry out. You're not living at that 6 or 7 day window where you're not irrigating, right? So that's one thing. And I'll actually bring up here just so you understand what I'm talking about when I say my crop booster, I want to kind of give you an idea, what we're talking about so you understand. All right, let me pull this up here. Okay, get the whole Zenivix. So this is one of the things in our presentation when we're going over our crop booster and how it works with our particular our system. Now, interestingly enough, when you look at how plants absorb water and nutrients, it's kind of a flow, right? It flows from the roots up through the leaves. What happens is when everything is healthy, when the plant is healthy, the roots are healthy, what happens is it'll absorb water and nutrients like you see on the bottom here from the roots, and it will go up through the roots from in a capillary fashion. So it will absorb nitrogen, phosphorus, potassium, those types of things, plus the water. And it will carry that through the plant and up through all the way to the leaves, right? That's just how it normally functions. But what we tell farmers and what happens to be the truth is when plants are under stress, some of these cells within this pathway become blocked. In other words, the cells no longer communicate at the same frequency and the same rate as the other cells. And that essentially turns them off. And that means that basically the water and nutrients now have to travel around those dead cells in order to get to the leaves to get to where they're going. And that can dramatically reduce the amount of concentration of certain minerals and certain water concentrations. Now, the interesting thing is, and I'm going to uh, go into a different presentation or a different slide here. I want to show you this. So we look at what the limiting factors of photosynthesis are, right? Because photosynthesis is a process and it needs certain things, as we all know, to survive. It needs light, for example. And this particular web page I found called StudyMine, it actually tells you what the limiting factors of photosynthesis are. And this is important to keep in mind from an agronomy level because you want to know what is going to be that sweet spot that's going to maximize photosynthesis in plants. Okay. And you look here that light intensity is one of the things. Like as light intensity increases, so does photosynthetic reactions. In other words, that plant is generating more energy as the light intensity increases. And of course, eventually it gets to the point past its optimum where now you're actually no longer getting an increase in intensity. It's as the intensity of light increases, you're no longer getting a more photosynthetic activity, right? Because too much light is actually going to start baking the plant and causing too much heat and other problems, right? And you look at temperature, that's a very big factor. And you see here this graph, how temperature, as it increases again in a linear fashion, it will improve the rate of reaction up to the point where it's optimum. Okay. And once you pass that optimum point, and that will vary from different types of plants, all of a sudden the rate of reaction falls, like it cascades down, right? And that's where you start seeing the plant really stop producing energy. And what we tell our farmers when we're talking about our crop booster is that our crop booster is actually making the plant more resilient. So we kind of flatten out this curve a little bit. So when it gets too hot, instead of just dropping off like that, with our curve, you're going to see the curve extend out further, and then it'll eventually still drop off. I mean, you can't grow in in lava or something like that, right? But you'll see this curve here, it will actually increase. So you have a much wider band of temperature where photosynthesis can continue to occur. Okay. But in general, once you get past a certain point of temperature, that plant is no longer going to produce photosynthesis. And even if it cools down or you add irrigation, it may take a while for that to ramp back up again. So that's why when we tell farmers they can increase their energy output during the course of the season by 30 to 70% with our crop booster, it's because just by flattening this little curve out and giving you more of a leeway on a hot weather type of a day, you're going to reduce that drop off and you're going to reduce the amount of time it takes for that plant to recover and get back to its energy production. Okay. Now, another factor, a limiting factor, of course, would be carbon dioxide. Okay. Actually, this is light intensity. I think this is carbon dioxide. Nope, temperature. Okay. So, you see, carbon dioxide is one of the things too. It has to have enough carbon dioxide. And a lot of times that's not really a problem if in an outdoor farm. If you have an indoor farm, a lot of times they'll pump more carbon dioxide in there because they want to increase that concentration. That's one of the reasons why they say hydroponics and other indoor farms are more efficient, right? But here, when you have a higher carbon dioxide coefficient, you see that that actually increases the rate of reaction much farther with light intensity. So in other words, it will produce under intense light conditions, it will produce a lot more photosynthesis, a lot more sugar. And that's one of the reasons why those types of things tend to be more efficient. Okay, and the last thing you want to see, yep, and that's it. That's all we got for that one. But really, the whole point of why I'm telling you all this is because if you really want to maximize your energy production, way back here, sorry, it's like my back to my screen here. Sorry about that. No, but the reason why we're talking about this is because when people use our crop booster, one of the things they need to know is how do they adjust their fertility schedule? How do they adjust their watering schedule? Because water is a part of that too. And of course, if we have a consistent and organized irrigation pattern, people will say, well, how does this affect irrigation or inputs? Well, I'm going to show you one more thing here, and this has to do with your irrigation schedule. And again, with the crop booster system, what we are seeing is that farmers that are irrigating more often but with quite a bit less water can actually get a much healthier, more productive plant with less water and less inputs. I'm going to show you why. So for example here, let's say your irrigation schedule is once a week, and let's say every Friday you start at 8 o'clock. Oops. You start at 8 o'clock here, and you're going to go from 8 o'clock and just irrigate all day long. So you have a 10-hour irrigation cycle from 8 o'clock in the morning to, let's say, 6 at night. Okay. and you're only going to irrigate that one day, right? Well, what happens at Saturday? Okay, there's still plenty of moisture in the soil on Saturday. On Sunday, still some moisture. By Monday, you're kind of drying out a little bit, and then Tuesday, you're probably kind of dry. And now that Tuesday, Wednesday period is where, like I just showed you, the photosynthesis in the plant starts to wane a little bit, starts to drop. Why? Because there's not enough moisture in the soil and not enough nutrients in the plant that doesn't have access to it. So it starts to do that downward curve. So for these last 2 days in your cycle, that efficiency of photosynthesis is dropping. Okay. Now again, our crop booster can help with that, but just your normal growing patterns here, it will actually start to drop. Now, what happens when you irrigate again on Friday? Well, it starts to come back up again because now it has the water, carbon dioxide, and the nutrients that it needs. And again, for that 3, 4, or 5 days, it's probably going to have enough to be fine and to be able to continue on with photosynthesis, right? But now, what happens when we take this same cycle and we say, okay, we're not going to irrigate um, twice a week or once a week. We're going to irrigate twice a week, right? So let's say we have Tuesday and Friday, but we're only going to irrigate 4 hours here, right? So 4 hours here and 4 hours here. Oops, it's not going to let me highlight it. But let's say we just do these two cycles here for 4 hours and 4 hours. Now, compared to one day at 10 hours, you're using a lot less water because over the course of a week, you're only doing 8 hours. So you're saving 20% of your water usage over the course of that week, right? You're also, if you're fertigating, you're also saving your fertigation by about 20% too, just by irrigating twice a week, because now what you're doing is keeping that consistency. Okay, and that's really what you want. The plant will generate its maximum benefit when it has consistent water, consistent nutrients, consistent sunlight as much as possible. And we can't control the sun, we can't control some of the weather and other things, but we can control the consistency of how much moisture is in the soil and how much nutrients are in the soil. So if we're able to irrigate more often and fertigate more often, but with less time, significantly less time, it's not just irrigating twice a week. Okay, it's irrigating, or it's not just irrigating the same amount, but just splitting it in half. You're actually reducing that amount of water and nutrient usage, and you're able to get the maximum benefit. And you're able to actually save 20 to 30% of your water in many cases. In fact, one of our growers said he was able to save 20 to 30% of his water even without the crop booster. Of course, then when he added the crop booster, he's actually saving a lot more than that because we're making the plant so much more efficient and so much healthier. Okay. So if you guys want to learn more about how you can get your farming operation much, much more efficient, save yourself a lot of money, and of course, with our crop booster, increase the efficiency even higher so that you get high yields, good quality, and with less inputs, then give us a call at 727-324-6750 or email us at service@harvestharmonics.com. Or, of course, go to our website at harvestharmonics.com and fill out our web form. We would love to work with you to help your farming operation become as efficient as possible so that you can become part of the future of farming right here today. Talk soon, guys.